Good morning everyone. In this video, we'll see transient response for DC input using Laplace transform. So we'll take a RL series circuit. So in this, resistance and inductance are connected in series with the source voltage. So this is excited by a DC source voltage. The voltage value is V. So we can apply when the switch is closed at t is equal to 0. We can apply Kirchhoff's voltage law to write voltage equation. So by applying Kirchhoff's voltage law, the V is equal to total voltage V is equal to sum of voltage across resistor and voltage stored in the inductor. So V is equal to VR of t plus VL of t. So V is equal to, and voltage across resistor is nothing but I into R. So VR becomes R into I of t. Similarly, the voltage stored in the inductor is given by L into di of t by dt. So now we have to take Laplace transform. So V becomes V by S and R into I of t becomes I of S plus L into, it is a differentiation, so it becomes L into Si of S minus I of 0. This I of 0 indicates 0 initial conditions. Since we don't have any 0 initial conditions, this I of 0 is considered as 0. So the above equation becomes V by S is equal to R into I of S plus L into S I of S. So I of S is common, you take I of S common outside, so it becomes I of S into R plus Ls. So I of S is equal to V by S into Ls plus R, and now we have to rearrange this form such that it should be S plus format. So I of S is equal to V divided by, if we take 1s from this L, then it becomes Ls into S plus R by L. So now we can apply partial fraction to take inverse Laplace transform. This is not in the format of inverse Laplace transform, so we go with the partial fractions. So now partial fraction is applied for this above equation, and the A and B values are determined, and the equation of us I of S is equal to V by R divided by S minus V by R divided by S plus R by L. So this is in the format of taking inverse Laplace transform. So 1 by S becomes 1. So I of S becomes I of t, and V by R is a constant, so it is kept as it is, and 1 by S becomes 1 minus V by R is a constant, it is kept as it is, and S plus R by L is in the form of S plus A. So the formula for this is e power minus at. So in the place of A we have R by L, so it becomes e power minus R by L into t. So finally we can take V by R as a constant, common outside. So I of t is equal to V by R into 1 minus e power minus R by L t. R by L can be taken as A, so that I of t is equal to V by R into 1 minus e power at. So the current response of RL circuit is shown in the figure. So it reaches its steady state after its maximum value. So this is all about transient response for DC circuit, RL DC circuits. Thank you.